Hello. Well, I'm sure that this introduction to complex numbers in these last few videos brought a lot of joy to your life. For instance, you know more numbers now, and you know how to operate with them, and you can now apply the quadratic formula and solve any quadratic equation, even if the discriminant is negative. So this is awesome. I'm just going to show you one more joy that complex numbers bring to us. This is related to the difference between two squares factorization. That's when we have a minus b squared, and your mathematical instinct tells you immediately that if you want to factorize this, you need to write a plus b multiplied by a minus b. And that should be an instinct to you by now. Now let's say that instead of a squared minus b squared, so instead of the difference between two squares, you have a squared plus b squared, so you have the sum of two squares. And this is what you want to factorize. And we are going to show that this is possible thanks to complex numbers. Let me write that a squared plus b squared can be also seen as a squared, and then I'll write minus b squared times I squared. Okay, let's check that this is true. The a squared is the same. I just changed the sign over here. You can imagine this change of sign as writing minus b squared, right? You could write a squared minus b squared. That'll be fine, right? Okay, but then one of the minus, I wrote it as I squared because I squared is negative 1. So now we can apply the formula above. We have a squared for the first term. So I'm going to write a plus something. What is going to be my something? Well, my something is going to be b times I. And then I'm going to have a minus the same term, bi. Yeah, so here just I'm seeing this as bi, all of that square. So, ta-da! This is the sum of two squares factorization. So we wrote a squared plus b squared as a product of a complex number, a plus bi, and a complex number that has sign change. And so that's the complex number and multiply by its conjugate. That's how this number over here is called. Let's see some examples. We want to solve by factorization the following equations. X squared plus 5 is equal to 0. So our number 1. So I'm going to write that x squared plus 5, according to our sum of two square factorization, is equal to x plus square root of 5i times x minus square root of 5i. So a will be in this case x, and b will be in this case square root of 5. So we square root of 5 to get 5 on the second term. We want this to be equal to 0. So we need either x to be the negative of square root of 5i or x to be square root of 5i. And those are our two solutions. Let's try now for the second example. 9x squared plus 1 is equal to 0. So we want to factorize 9x squared plus 1. We can see this is 3x, all of that square plus 1 square. That's another way of writing 9x squared plus 1. So applying our formula for the sum of two squares, we can write this as 3x plus 1i, so 3x plus I, multiplied by 3x minus 1i, so just write minus I. And this is what they want to be equal to 0. By null factor law, we have two options. Either x has to be a negative I over 3 to make the first bracket equal to 0, or x has to be I over 3 to make the second bracket equal to 0. And those are the two possible solutions that we have.